back to my YouTube channel. Today we'll be designing a timeline. So you must have been using Facebook, Instagram, these type of social networking sites where you can see posts of your friends, someone you follow. So yes, that timeline page where you see all the feeds. Today we are going to design that. So this social networking site design is separated in quite big. So we have separated it into multiple videos and multiple topics. So today we'll covering this timeline thing. And next, in upcoming videos, we'll be seeing how the posts are created, likes, views, counts are there, and there are other topics as well, like how you create a friend's recommendation, everything we'll covering on. So let's start with designing a timeline. Let's suppose in an interview, if this question comes up, what an interviewer wants you to know is from you to know is uh, these functional requirements, like uh, you have to design a timeline service and it should be used for both type of users, normal and celebrities. By celebrities, I mean someone who has millions of followers. So if someone is following that celebrity, then the post of that celebrity should reach to all their followers. Non-functional requirements are it should be highly available and very much scalable. For now, we have taken daily active users at 1 million, and we suppose that 10% of them post daily, like 100K posts uh, are there daily. And out of active users, we suppose like 0.1% are celebrities, so that comes around 1K. And if once that post is added, it should remain a system that will come in our video where we'll be discussing how posts and photos, videos, reels, these all are handled. Okay, so designing a timeline service, there are two mechanisms. We can say it as a fan out service. So there are two type of fan outs present. Or you can say there are only two ways you can do fan out. Fan out what by I mean like as soon as you post something, it has to fan out or reach to all the users which are following you. So we are spreading your posts all across your followers or friends. That is what fan out is. So there are two type of fan outs, which is fan out on read and fan out on write. Okay, so we'll be discussing like what are the differences, how these two work, and which fan out mechanism we should follow. First is fan out on read. So what fan out on read means, let's suppose is A has posted a post and B is a follower of A. So what this will fan out on read will do is like as soon as B comes online and he comes on his newsfeed page or timeline page. So he will request, hey, I have been following A, and if there is something new post by A, please give me. That is when B is trying to read, then this fan out is happening. Then we are fetching posts from A and then showing him to B. Okay, this is fan out on read. Now, what is fan out on write? We'll take similar example A and B. So in this, what we'll do is, let's suppose as soon as A upload something, anything. So what we'll do is we will cache that data and save it for B because we know that we will be reading that thing. So we pre-computed B's data. This is fan out on write. Okay, and which is better? So if we see which is better, both have their pros and cons. Let's discuss that. So what is the pro of fan out on read? Fan out the pro of it this is that we are not pre-computing data, so our resources are not that much utilized. We can save on resources, but the con is it is very time taking, like to go and read, fetch data for any user. This is not that much scalable. If we come to fan out on right, the pro here is since we are caching data, it is very fast for generating a timeline. But the problem occurs where, let's suppose, you have millions of followers. So what are you gonna do? Are you gonna write the cache for all the million users as soon as you upload post? No, because there are chances that most of the users don't come online. So we don't want their data to be cached. There's no need of that. Okay, so that is where our resources are wasted. So this is a big con of fan out on right. But what we are going to do here is we will be following a hybrid approach where we'll be using fan out on write for normal users and fan out on read for celebrity users. Okay, you will understand as soon as we go deep dive into our design. So yeah, this is the design which I have come up. It is a big design, but you'll understand easily. Let's suppose, so yeah, let me also tell you that this fan out on write is called a push model and fan out on read is called a pull model. Let's see the design of a push model, what in push model we do. Okay, so since it is a very big system, where is so many much of users, we are following microservice architecture where we have distributed uh, different responsibilities to different services. Okay, like for now, I have come up with this post service, friend service, user service, and timeline service. These four services I have come up with. So as soon as someone upload some post, that post service will post save that data in some database, for sure. We'll discuss this later on in another video, how what type of database this post service use and how it is saving photos and videos and managing these, managing likes, comments, etc. So we'll cover it in another video. Okay, so in post survey, as soon as this new uh, post comes, what this post service do is it will contact this post service to user service, like what type of user it is. It is a normal user, a celebrity user. So we can identify what type of user that is based on multiple factors. The major factor which here we can use is number of followers. Like if someone has more than X followers, we will consider him as a celebrity. Okay, so user service will have that information. So as soon as someone uploads a post, the person who uploaded a post is identified as a normal user. So what it will do is it will push a message to this queue. So this queue and this queue will have post ID and user ID. So this queue will have post ID and which user has uploaded it, that user ID. Okay. So this queue will be listened by consumer, our push consumer. So we will be always obviously having multiple instances of this consumers so that it can process things faster. So what this consumer will do, this consumer will ask what all friends are, uh, what all friends are of this particular user. For that, it will contact friend service or follower service, whatever you want, we can call it. This friend service has information of which user have what, how many friends, and what are all our friends. They have information for that. Okay. So this push consumer will ask who are friends of this user. So the list of users it will get, and also we have this settings like whom we want to who wants to see our post, who don't want. So these all information we do na? Like if I have muted someone or I don't want to see any post of that user, these all things we do. So these all information this front service will have. Based on that information, it will return the data of how many users you have to cache data for. Like let's suppose we have user A. User A. So user A is someone who is uploaded a post, and he have friends called B, C, D, E, F. Okay, so these are friends of user A. 1 second. Uh, yeah, so these are friends of user A. But let's suppose B says that I don't want to see. Similar thing is said by C or maybe E. Okay, so if B and E says I don't want to see that post, so what will it do? It will simply, it is not visible, too big. Yeah. 1 second. Yes. So if they say that I don't want to see the post, so what this friend service will return is it will return only the list of user who want to see the post of A, like it will not return 1 second. It will not return B and E, so it will return C, D, and F. Okay, so now what we'll do is we will this push consumer will save this data for C, D, and F in one Redis. Okay, by this I mean like something like this. Uh, like let's suppose the B it has post as P1 and A has post as P1, so it will have uh, so now since A has post P1, so uh, it will C, D, and F will have list of posts, and it will include P1 in this Redis. Okay, so this type of data will be saved in Redis cache, so that if C comes and say that hey, I want to see all posts which I should see, so we'll see this list and all the posts in this list will be returned. Okay, so we have pre-computed data for C now in this Redis cache. Just remember, this is the push model only. We will come to pull model or fan out on read as soon as we complete this. Now, let's suppose B, D, or F, anyone comes online. So he will ask, here timeline service, I want to see post which I should see or my friends have posted. Okay, so this timeline service will read posts from this cache. So it has information of which user he wants to see. Let's suppose for C. So for C, he says, hey, there is one post called P1. So P1 it will be he will get timeline service get P1, and it will hit again the post service. It will hit this post service to fetch details of P1 post. So post service will return him the details of post P1, and it will return to the front end that these are the posts you are going to show. Now, as soon as this timeline service is also sending them these details, like this post P1, it also sends an URL with that post. What this URL is? It is a callback URL, or we can say callback API. As soon as C sees that post, this front end will hit this API, and that API will come to timeline service, and it will know that user C has saw that post P1, so it will go and delete that post from this Redis. So now, again, if C comes to refresh it and she want to see that new post, he will not see post P1 because he has already seen, and it will not be there in the timeline. Okay, so this is what this timeline service will do. Now, this is, I think, the flow of our uh, push model is done. Now we'll come up to pull model. What will happen if one celebrity uploads a post? As soon as celebrity uploads a post, uh, we will not push message in this queue because it is not a normal user, and the information of that user we'll get from obviously user service. Okay, so we'll not push that message in this queue. What else we can do is, if that celebrity, we can have different tiers of celebrity. If that is a very famous celebrity, let's suppose Virat Kohli is there. So everyone, most of the people in India will be requesting to see posts of Virat Kohli. Or, I mean, that is very obvious. Okay, so for that kind of celebrities, we can maintain some cache where we can have like celebrity ID or user ID and the post. Okay, else this post service won't do anything for pull model. So now what happens in timeline service? Let's suppose for C follows Virat Kohli. So as soon as this timeline service will do, it will be fetching this data from Redis and post details from post service. In parallel, it will also hit this celebrity uh, celebrity post service. Okay, so this celebrity post service will fetch posts for the celebrities which she follows. For our example, he is following Virat Kohli. Okay, so as soon as this celebrity post service get user ID, see what it will do is it will fetch what all celebs she follows from friend service. It will get or follower service, whatever name we can give to this service. So it will fetch that data, and it will get the celebs ID, and from this cache we'll get the post ID. Okay, so now we have got the post ID. So what we can do is we directly hit the post service and fetch the post data. So this timeline service is still it is doing that. So what will happen? Let's suppose things are happening is in parallel is let me show through a design. Uh, what is happening is this is this is I'm saying like timeline service is fetching normal user post. Okay, so this timeline service is doing something like that. This in parallel, timeline service is also uh, timeline service is also fetching uh, uh, posts from celebs, from celeb service. Okay, so these things are happening in parallel. So now we will get post ID from both these services, and now timeline service will hit this post timeline service. It will hit post service to fetch post details. So we are getting post ID from this set of operation. where timeless service is hitting the cache, and from again we are getting post ID from post select post select post service. So there is a net API call from here. So these two things are happening in parallel. And after getting the post IDs, we'll club that post IDs, and we will then show that hit the post service to fetch data from post service and show these details to user. Okay, so now like this, user will able to see all the posts both from his friends and celebrities he follows in one go. And as we know, there will be a callback URL which we will let us know that what all posts this user has seen, so that we can do that type of computation, and let other services know that don't send posts for this user again because he has already seen that. I think that's pretty much from this design. It will solve our problems since we have used microservice architecture, so it can handle different responsibilities and we can scale them differently. We are using caching here, so it will be fast. It will be scalable also. Uh, uh, we have seen like how to handle such traffic, so we can scale easily since it is microservice architecture. We are using asynchronous queues also for saving data. We can scale consumers also independently. So yeah, I think this design is very much scalable, and it is also highly available because it doesn't depend upon only one service. There are multiple services engaging, and we have multiple instances of that service as well. Okay, so I think that's pretty much. Uh, Please do let me know what else system design question you want me to tell solution of our design, so that it can help in your interviews of system design. These type of questions are asked in most of the companies, product-based companies you go. So yeah, if you tell this question comes, please let me know that what solution you gave, and if this is a solution you gave, let me know that it helps or not. Okay, you do like my channel and subscribe. Thank you.